Good afternoon, students. For the today's session, we are going to deal with the topic called as decoder. Decoder is the second bit of your second module. Okay, so decoder, as the name says, it decodes. Code is decoded with the help of a logic circuit called as decoder. Okay, so into this, basically how it looks is in this fashion. So basically a decoder will have n number of inputs and it will have 2 raised to n number of outputs. For example, if you have 2 input, it means 2 inputs 2 raised to 2 outputs. It means 2 inputs 4 outputs. If you have 3 inputs, it means 2 raised to 3. 3 inputs 2 raised to 3 means 8 outputs you will have. Okay, so let us see what is the definition of this. Okay, so decoders are a class of combinational logic circuits, okay, that convert a set of input variable representing a code into a set of output variable representing different code. Okay, it means input codes and output codes are completely different from each other. Okay, so the relationship between the input and output will be written in the form of a truth table. So we will see the truth table later. Okay, so this is the general structure of a decoder. Okay, so what difference we have from this to normal thing is you have one more input to this, that is called as enable input. Okay, enable means what is, these are also called as select lines. Basically from this enable input I am going to select any of the output which I want. Okay, decoder into this, if I have, say for example, 2 inputs 2 raised to 2 means 4 outputs. Okay, it means so at a time I need not access all the 4 outputs. Okay, so it means output number 0, output number 1, 2, 3, I will have these 4 outputs now. Okay, so at a time I can access any of the one output and that accessing is given with the help of enable input. Okay, so we will understand this much deeper into our next thing. Okay, so now we'll come to the next thing, that is called as a binary decoder. Binary decoder means what? The difference between this and the previous one is that in a binary decoder, okay, so if there are into this the same thing, 2 inputs 4 outputs, that is 2 input n input 2 raised to n output, same thing. But the thing is, into this binary decoder only one of the output is high. Okay, one of the output is high. For example, this is the truth table for this. Okay, see here I have written 2:4 decoder, means 2 inputs 2 raised to 2, that is 4 outputs, right? So these are the inputs A and B and these are the outputs Y0, Y1, Y2 and Y3. Okay, so here when you see, okay, so what you can do is see here A, B, so this is 0, 1, 0, 1, changing by 1 bit, again changing by 2 bits, 0, 0, 1, 1. Okay, I have one more input called as enable input as like this before. Okay, so what we do with this enable input is I am going to keep it 0. When this is a 0, you are not caring what it is. Yakandre enable is 0 means none of the output will be active at that point. Okay, so if enable is 1 means you have any of the outputs out 1. What are those? We will see it now. Okay, so see here, so if you look into this, see when enable is a 0, all the outputs Y0, Y1, Y2 and Y4 all are 0. Now when enable is 1, all for all 4 cases, okay, so this output Y0 is 1 when both A equal to 0 and B equal to 0. Similarly, Y1 is equal to 1 when only B is equal to 1, A equal to 0. Y2 is 1 when A equal to 1, B equal to 0. Similarly, Y3 is equal to 1 when both A equal to 1 and B equal to 1. It means, okay, it another sense, any one of the output is high at one particular output. Artha agutta? So for this logic, only this Y0 is high. All Y1, Y2, Y3, Y1 all are 0. Okay, for this particular logic, A equal to 0, B equal to 1 means it is what? A bar B. For A bar B, what is high? Only y1 is high. Other three logics are 0 there. Similarly, for this logic, that is A equal to 0, A equal to 1, B equal to 0 means what it is? A B bar. What is active? Only y2 is active, whereas other logics are at logic 0. They are at logic low value. Similarly, when both are high, okay, y3 is active, whereas other logics are at logic 0. So if same thing I have interpreted it over here, y naught, when is y naught high? When A equal to 0, B equal to 0. A 0, B 0 means what it is? A bar, B bar. Similarly, y equal to 1. When it is A equal to 0, B equal to 1. A equal to 0 means what it is? A bar, B. Similarly, y2 is equal to 1. When what? A equal to 1, B equal to 0. So, it is what? A, B bar. Similarly, y3 is 1 when what? Both A and B are at logic 1. So, that is A into B. Okay. This is the logic diagram which I have plotted for that. See, you can see here y naught equal to A bar B, y1 equal to A bar B, y naught equal to A bar B bar, y1 equal to A bar B, y2 equal to A B bar and y3 equal to A B. Right, see here what I have done, I have two inputs A and B. I have put a NOT gate. When I put a NOT gate, okay, A will become A bar, B will become B bar. Okay, so I have all now A, B, A bar, B bar available to me now. Okay, so what I have done, I am going to put it into the gates and I am going to tap the outputs over here. Okay, so what is this? This is B bar and this I have tapped is nothing but A bar. So what do I get? A bar, B bar, and what it is? Y naught. Similarly, what is Y1? A bar B. So what it is? A bar. So I have A bar over here, and where do I have B? So B. So B I have tapped it, and what do I get? A bar B. So this is your logic Y1. Similarly, what is Y2? Y2 is nothing but A B bar. So this is A. I have tapped it from A, and where do I get B bar? So this is line B bar, so I have tapped B bar. So what do I get? A B bar. So this is your Y2. Similarly, what is Y3? Y3 is equal to A into B. So this is A and this is into B. So what do you get? A into B. This is nothing but Y3. Then where do you have enable pins? So what I have done is I have put an enable pin and I have tapped it to all the 4 gates over here. Okay. So it means only when this enable is high, enable input, when it is high, this logic. Okay, so this logic is high. When this is 1, this logic is high. When this is 1, this is high. When this is 1, this is high. So at one point you can access any one of the output. Okay, so this is the beauty of your binary decoder. Okay, so the same thing I have explained it over here. On the similar lines, you can see a 3:8 decoder. So when I say 3:8 decoder, it means there are there are 3 inputs, n inputs, 2 raised to n output. It means 3 input is to 2 raised to 3 output. It means 3:8. So this is a 3:8 decoder. Okay, so we are going to see how it is. So presently you are seeing the truth table for a 3:8 decoder. Okay, see here what I have done: A, B, C, 3 inputs, and you have to have 8 outputs. So 0 to 7 means how many? 8 outputs: Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Okay, so this is again the same enable input. So this is a 0. When none of the output are high, so this enable is a 0. Okay, so therefore I have written don't care for all the input variables over here. Okay, so see here you can see this is this is marked over here. Okay, so Y0 is high. So when A equal to 0, B equal to 0 and C equal to 0. Similarly, Y1 is high at this logic, Y2 is high at this logic, Y3, Y4, Y5, Y6 and Y7. Okay, so this is nothing but the truth table. So at one particular time, only one of the output is high. Okay, so this is the beauty of what? This is the beauty of a binary decoder. Let us see the logical diagram for this. Okay, so as you can see, if I want to write y naught, so what is your y naught logic? So this is nothing but y naught. Okay, so what it is? A equal to 0, B equal to 0, C equal to 0. Means what it is? A bar, B bar, C bar. Similarly, what is y1? Y1 is high when 0, 0, 1. A bar, B bar, C. Right, so A bar, B bar, C. Okay, so similarly, I have written the other logics. So as you can see, I have written it over here. Okay, that is y naught when a0, b0, c0. Similarly, y1 at 0, 0, 1 bar, a bar, b bar, c. So y2, so what is this? This is y2 1 when what it is? 0, 1, 0 means y a bar, b, c bar. A bar, B, so B, C bar. Similarly, Y3, so when it is 0, 1, 1 means A bar, B, C. Similarly, I have written it for other logics. Okay, so if from this, if I want to draw the logical diagram, this is how the logical diagram looks like. Again, we have taken three inputs A, B, C, and we have taken the particular NOT gates. So C becomes a C bar, B becomes B bar, and A becomes A bar over here. So what do I have for Y naught? Y naught is A bar, B bar, C. So we have tapped A bar, B bar, C bar, and also we have to tap one more pin, that is enable pin. Similarly, A bar, B bar, C. So A bar, B bar, C. So similarly we have done it for others also. So what do you have for Y2? A bar, B, C bar. So A bar, this is B, okay, and this is a C bar. So similarly Y3, what do I have? A bar, B, C. So this is A bar and this is B and this is logic C. Similarly Y4, it is A, B bar, C. So this is A, B bar, this is C. Similarly for Y5 and Y6. So what we have done is all the inputs we have tapped and we have given it to one pin, that is enable pin. Okay, it means this pins will be active only when this is enable pin is at logic 1. It is at logic high, then only all the pins will be active. Next we come to a standard decoder. Okay, so this is a standard decoder which is available commercially into the markets. Okay, so the name of this is 74X138. Okay, so 3 means what? 3 inputs, 8 outputs. So 3:8 decoder is available. Okay, so we are just going to study how it is. Okay, so basically the logic with this is you have a different output, different kind of outputs and inputs to this. Okay, so basic things remain same, that is there are 3 inputs, A, B, C are inputs. Similarly you have 8 outputs, so Y0 to Y7 you have 8 outputs. Okay, so to this you have 3 enable inputs. Okay, so what are those we are going to see? That is 2 are active low and 1 is active high. So we will understand what you mean by this. Okay, so this is nothing but the logical symbol of this decoder, that is 74X138. Okay, see here, into a previous session we did not have these bubbles. Okay, so only for certain things we have bubbles over here. Whenever I write a bubble, it means you are getting the knotted value of this. If you have 1 at this point, the output coming out of this is 1. Okay, so therefore if this is Y0 here, so when I write the output I have to write it as Y0 bar. This is Y1 here, so the output here is Y1, so Y1 bar, Y2 bar, Y3 bar, Y4 bar, Y5 bar, then Y6 bar and Y7 bar. Similarly here what do I have? These are nothing but A, B, C. So these are the 3 input lines and these are nothing but the select lines. Okay, so this is again G1, G2A, G2B. So these 2 pins again have a bar and therefore these are called as active low pin. Okay, active low means these have a NOT gate over here. You have to remember it over here. These are active low and G1 is active high. So it means normally for G1, however you write, you can write it as it is. But whenever you are writing G2A, G2B, you have to take care that you write, instead of writing it 0, you have to write it as a 1. This is the simple thing which you have to follow. And this is nothing but the function table or the truth table of this. See here, as I said before, instead of writing the output as y0, I am writing it as y1 bar, y0 bar, y2 bar, y3 bar. Okay, so A, B, C. So these frames your inputs. Okay, what are your select lines? G1, G2A and G2B. So these are your select lines. Okay, next, instead of writing it, since these are all at active low, so these cases which has a bubble are always called as active low. So since they are active low, so what you need to do, you need to write it with a NOT gate. So I have written it over here, y0 bar, y1 bar, y2 bar, y3 bar, y4 bar up till y7 bar. So how many inputs? 3 inputs, 8 outputs you have. Okay, since it is bar, you can't write 0. Okay, for this to be 1, you have to write, okay, for this to be active, you have to write it a 0. So as in your previous class, you wrote it as 1 here and other logics were 0, but you can't do this now. Why? Because this is these are active low gates. So this is the difference. So illen baritiri 1 bariyudilla, ulta 0 baritiri. Okay, so see here, so there are see here what we have done over here is we have left this, see here, so 3 don't care terms which we have included over here. Okay, so why, I will just tell you. So and from this you are going to write this. So that is what 0 1 0 1 0 1 0 1, 8 combinations. So 0 0 1 1 0 0 1 1, again 4 zeros 4 ones. Okay, so this is nothing but your input variables. Okay, so this is the input. Okay, so now if you see this, okay, so this y0 bar is active when A is 0, B is 0, C is 0. Again, so y0 1 is active when at this logic 0 0 1. Similarly, y0 2 is active at this logic, that is 0 1 0. Similarly with the other logics as well. Okay, so here G1 is what? Active high. So you can write it as 1. But since these both are active low, so you can't write 1. You are writing a 0 here. Why? Because you have NOT gates here. So right. So instead of writing it as 1, you are going to write them as logic zeros. Okay. So this is the only difference which you have. Again, the next one which we have is 74X139 dual 2 to 4 decoder. It means it is 139, means there are 2 to 4 decoder into this. Okay, so this is how the logic diagram looks like. Okay, andre 2 decoders ide idrolage. So this is one decoder, 2:4 decoder. This is another 2:4 decoder which you have. 2:4 means what? 2 inputs, 4 outputs. 2 inputs, 4 outputs. Okay, so what do you have over here? A, B. We have written 1 over here. So because this is first the 2 outputs, 2 gates. So this is the first gate inputs and this is the second gate inputs. You can see 1A, 1B means first gate inputs these are. So 1 y0, 1 y0, 1 y1, 1 y2, 1 y3 means these are the outputs of your first decoder. Similarly, so 1G means this is the gate, that is a select line or enable input for your first decoder. Similarly here, so AB, 2A, 2B means input of the second decoder, 2y0, 2y1, 2y2, 2y3, these are the outputs of your again the second decoder. 2G means the enable input of your second decoder. So again see here, these are all active low outputs, these are all active low outputs, and again the select lines are also active low, so you can't write a 0 here, you have to write 1 here, or you can't write it as y naught. Okay, you can't write it as y naught y1, you have to write it as y naught 1 bar, y naught bar, y1 bar, y2 bar and y3 bar for this. Okay, so this is nothing but the truth table for this. So as you can see here, this is again active low, so active low G. So into a previous case we had written it as we had written it as 0 1 1 1 1, but since it is active low we have to write it as 1 0 0 0 0. Okay, again two inputs, so again when it is 1 means you have a don't care term. Okay, so A 0 1 0 1 0 0 1 1, so these are all zeros. Okay, so again you can see that here at one particular time only one signal is high. Okay, so y naught bar is high when a equal to 0, b equal to 0, y1 bar is high when a equal to 1, b equal to 0. Okay, similarly y2 bar is high when a equal to 0, b equal to 1, or at a bar b. Similarly y3 bar is high when both a and b are 1.